Let's begin with the core idea. Set theory in CAT is not about memorizing circles, it is about translating language into structure and structure into speed. The real goal here is to stop treating every question as a drawing exercise and start seeing the logic behind unions, overlaps, and exclusions. That is why this topic matters so much in the exam. Once the language becomes clear, the question becomes much easier to handle. Now let's build the basic language properly. When two sets are combined through union, you are talking about everything that belongs to either set, including the overlap. Intersection is narrower. It is only the common part shared by both sets. Complement means everything outside a chosen set, but still inside the universal set. Mutual exclusivity means no overlap at all. The universal set is the complete group under discussion, and the neither region is everything outside the sets but still inside that universe. Here's a trap you need to be aware of. CAT often hides meaning inside ordinary words like only, either, neither, and at least one. Now that the language is clear, let us move to the formulas, because these are what save time under pressure. The two-set master equation tells you that if you add the sizes of two sets, the overlap gets counted twice, so you subtract the intersection once to correct it. The three-set expansion works on the same logic but in a larger structure. Add all singles, subtract all pairwise overlaps, and then add the central region back because it was removed too many times. The important exam habit here is not just knowing the formula, but understanding why it works, because that is what helps you avoid misplacing regions in a diagram. Most aspirants confuse a word like only with at least one, and that is exactly how traps are built. Let us apply the logic to a fraction-based question, because these are common in CAT and also very easy to mishandle if you rush. The question gives a total of 240 people, with half in one class, 1/3 in another, and 1/4 in both. The clean way is to convert each fraction into an absolute count first, then subtract the overlap from each set, and only after that calculate the union and the neither group. The key idea is simple. Do not jump directly to the final answer without first fixing the overlap. A good way to remember this is that overlap belongs to both groups, but when counting distinct people, it must be counted only once. Here is a faster approach. Instead of carrying the real total through every step, you can work with the least common multiple of the denominators as a base. The denominators are 2, 3, and 4, so a base of 12 units makes the ratios easy to manage mentally. Once the set sizes and overlaps are expressed in units, you convert at the very end back to the real total. This is useful because it avoids heavy arithmetic in the middle of the question. In CAT, the real advantage is not cleverness for its own sake. It is reducing the number of places where calculation errors can happen. Let's decode the pattern behind the previous questions. Whenever the data is given in fractions or percentages, you should pause before computing actual numbers. That is your first signal that an assumed base may be better than the real total. For percentages, the natural base is 100. For fractions, the natural base is the LCM of the denominators. Then you perform the set operations on that simplified base and scale it back only at the end. Another important correction. If you forget that the overlap has already been counted inside both sets, you will double count and the answer will drift. Now we enter a more difficult category. Three-set problems with raw numbers. Here, the challenge is not the formula alone, but organizing the information without losing track of what belongs where. The standard method is to assign variables to each region and build equations from the totals. For the survey example, the totals for each magazine, the overlap count, and the at least two count all interact. The important distinction is that at least two includes both the exactly two regions and the all three region. That is the part many students miss under pressure because the phrase sounds broad but still hides a precise mathematical structure. Here is the faster structural method for the same kind of three-set problem. Instead of solving every region separately, CAT often rewards direct use of the union structure. Total union can be expressed in terms of the singles, the exact 2 overlap count, and the exact 3 overlap count. In the example on the slide, the sum of the single set counts is 71. The at least 2 information lets you reconstruct the exact 2 and exact 3 parts, and from there, the union becomes 54. Once the union is known, the none group is just the remainder from the total population. This is the real exam skill here. Move from messy data to the few counts that actually matter. Now let us distill the lesson from the previous 3 set problems. If a question gives you the individual set totals and also gives a combined overlap clue like at least 2, then drawing a full Venn diagram first is often a waste of time. The better move is to recognize the algebraic structure immediately. Memorize the aggregation logic. The sum of the individual sets contains the exactly 1 regions once, the exactly 2 regions twice, and the exactly 3 region 3 times. The union can then be recovered by subtracting the extra counts. A common mistake is to confuse at least 2 with exactly 2, but those are not the same at all, and CAT will absolutely exploit that difference. It's time we switch to a trap that looks like a standard overlap question, but is actually built on incompatible categories. In the example, men and women are mutually exclusive groups, while dentists is an overlapping trait that can apply to either group. The mistake many students make is to force all 3 into a Venn diagram as though they behave the same way. That is the wrong model. When one category is a partition and another is a trait, the clean structure is no longer a simple 3-circle Venn. The question wording either men or dentists can mislead you if you are not careful, because it mixes a category with a trait and hides the true counting logic. Here the right tool is a 2x2 matrix, not circles. Once you realize that men and women are mutually exclusive and dentist versus non-dentist are also mutually exclusive, you get a 2-axis table. That structure lets you place the total men, total women, total dentists, and the unknown intersections in a disciplined way. From the given data, the number of male dentists can be recovered first, and then women dentists follow immediately from the total dentist count. This is exactly the kind of situation where CAT rewards correct modeling more than brute force diagramming. If the categories are binary and fixed, a matrix is usually cleaner than a Venn diagram. Let's make the correction explicit. When the data is organized into 2 fixed, mutually exclusive classifications, forcing a Venn diagram is a structural error. A Venn diagram works when overlap is fluid and all circles can intersect meaningfully. But when the categories are locked into a grid, the 2x2 table preserves the logic better and reduces confusion. That is why the slide crosses out the Venn approach and replaces it with a table. The exam takeaway is simple. Choose the representation that matches the nature of the categories, not the one that merely looks familiar. Now that the core methods are clear, here is a shortcut playbook for high-speed problem solving. The first rule is about wording. When a question says at least 1, the neither region is automatically 0. So total population becomes the same as the union only when everyone is included in at least one set. The second rule is formula bypass. If total and overlap are already given, there is no reason to redraw everything from scratch. The third rule is the unknown center habit. In a 3-set Venn, always fill the center first because it anchors the rest of the regions. The fourth is reverse engineering from options, which is often faster when the arithmetic becomes messy. Let's compress everything into a usable revision framework. First, remember the golden formulas. 2-set union, total population as union plus neither, and the 3-set expansions for both union and sum of sets. Next, translate CAT language carefully. A or B means union, A and B means intersection, only A means A minus the overlap, and at least 1 means union with no neither region. Then keep the diagram rules in mind. Binary categories belong in a 2 by 2 grid, not a Venn. Fractions and percentages should be normalized to an easy base. And in 3 set problems, the center should be fixed before the outer regions. Finish every question with the checklist. Identify what is asked. Check whether the data is absolute or relative. Decide whether a formula beats drawing. And confirm whether the none group has been handled. Follow that sequence and you are exam ready. Let's close with the main idea you should carry into the exam hall. Do not fight the question with circles. Solve it with logic. The faster you recognize the structure, the faster you convert language into counts and counts into the answer. That is the whole advantage of set theory in CAT. Precise reading, correct model selection, and controlled execution. Keep that discipline and you are exam ready. We hope you have understood the topic. For more such content, explore EduRev app.